Dear students, welcome to this discussion of the JEE advanced question papers of previous years for the benefit of IIT aspirants who have to write the advanced examination after a few days. Now here is a question from JEE Advanced 2022 question paper 1. It's a question based on organic chemistry. You are given a reaction sequence. The starting compound is CH3CH2COH, that is propanoic acid. And the first reaction is with bromine in the presence of red phosphorus, followed by treatment with water to get a compound P. And this compound P is now reacted upon with a compound whose structure is given here. And if you carefully look at the structure, you will see that it is the potassium salt of the compound thalamide. And you are reminded of the reaction Gabriel's thalamide synthesis. So once you see the molecule, you must immediately it must come to your mind that the reaction is the Gabriel's thalamide synthesis. Followed by reaction with alkali and then treatment with an acid to give a compound Q plus phthalic acid. And there are certain statements given, and you have to consider the statements and spell out what are the correct statements. So first of all, let us try to understand the conversions and find out what P and Q are. Actually, this propanoic acid, the reactions with the bromine in the presence of red phosphorus. So very carefully look at the reaction. It is reaction with the bromine in the presence of phosphorus. And actually you are reminded of the reaction, what you call the Hell-Volhard-Zelinsky reaction, the HVZ reaction. Hell-Volhard-Zelinsky reaction. And Hell-Volhard-Zelinsky reaction is the reaction of the acid with chlorine or bromine in the presence of phosphorus. In the presence of phosphorus, in which an alpha hydrogen atom is replaced by a bromine atom. So you have the compound CH3CHBr-COH. Okay? So that is a compound that you get. And of course, the treatment with water is to dissolve away whatever byproduct is formed in the reaction. And the product P is this compound, that is alpha bromopropanoic acid. And this alpha bromination or alpha chlorination by treatment with the chlorine or bromine in the presence of phosphorus is known as the HVZ reaction, that is the Hell-Volhard-Zelinsky reaction. Okay? And now this compound P is now reacted upon by, as I said, CON minus K plus, that is the potassium salt of thalamide. So potassium salt of thalamide reacts with this alpha compound. And what is the Gabriel's thalamide synthesis? It is a method of preparing primary amines, isn't it? By reaction of an alkyl halide with potassium salt of thalamide. So here you have the bromo compound. It is something like an alkyl bromide. And at this point, with the CHBr, the negative ion of thalamide, now that is something like a nucleophile. So this nucleophile will displace bromine from this position, and therefore the product that you get will be CO, okay, N, okay, you have CH, CH3, COH. So that is a compound that you get during the reaction with potassium thalamide. Remember that the thalamide ion is negatively charged on the nitrogen, and it's a nucleophile. So that nucleophile attacks the CBr bond, displacing bromine, and the nucleophile get attached to this carbon, forming this compound. And now this compound is subjected to alkali treatment, alkaline hydrolysis. So what happens is the phthalimide ring, this ring is broken by hydrolysis and the NH2 group is generated there. So what you get is the NH2 CH CH3 COOH. Okay, let me write here COH. So that's the compound that you get, plus the other compound formed is COOH. So these are the two compounds formed, and this one is given in the question, and therefore this is the compound Q. So that's all. Simple chemistry. Reaction of propanoic acid with the bromine in the presence of red phosphorus and followed by treatment with the water gives the corresponding bromo compound, the alpha bromo propanoic acid, and the alpha bromo propanoic acid reaction with the potassium phthalimide gives the phthalimide substituted compound, and this compound on hydrolysis by alkali NaOH, the ring is open and you have the amino compound. In this case it is alpha amino propanoic acid. You get an amino acid as a product. It is alpha amino propanoic acid, isn't it? Alpha amino propanoic acid, and the other product is benzene 1,2-dicarboxylic acid, or what you call tylic acid. So that is the chemistry of the reaction given. So now let us go to the statements. P can be reduced to a primary alcohol using sodium borohydride. Of course, P is this compound, alpha bromo propanoic acid, and what is given in the statement is that it can be reduced to a primary alcohol. The reduction of acid to a primary alcohol by sodium borohydride. It doesn't work. With sodium borohydride, it doesn't work. Whereas with the lithium aluminum hydride, it does work. Conversion of acid group to primary alcohol can be had by reduction using lithium aluminum hydride. You cannot have the job by using sodium borohydride. So the first statement is not correct, it is wrong. Okay? Now coming to the second statement, treating P with concentrated ammonium hydroxide solution followed by acidification gives Q. Of course, with ammonium hydroxide solution, what happens is the P will form the salt, ammonium salt, that salt, and acidification will regenerate P itself. You won't get Q. So the second statement is also wrong. Okay? Acidification of the ammonium salt. The reaction with the concentrated ammonium hydroxide will give the ammonium salt of the alpha bromo propanoic acid, and the ammonium salt on acidification will give the parent acid itself. You are not going to get Q. So second statement is wrong, right? And coming to the third statement, treating Q with a solution of NaNO2 in aqueous HCl liberates nitrogen. Q is an amino acid, so the amino acid is NH2 CH CH3 COH. The reaction is with the sodium nitrite and HCl, that is nitrous acid. Nitrous acid will react at the NH2 group, forming an unstable disonium salt which spontaneously decomposes to give N2 with the formation of alcohol. That's a reaction that you study in the chemistry of aliphatic amines. Aliphatic primary amines react with the nitrous acid to form an alcohol with the evolution of nitrogen, because the disonium salt is so unstable that even under the conditions of the reaction, the disonium salt decomposes to produce nitrogen. So it is conversion of the amino group to an OH group on reaction with NaNO2 and HCl. So the third statement is correct statement. Treating Q with a solution of sodium nitrite in aqueous HCl liberates nitrogen. That's a correct statement. Okay. And now coming to the fourth statement, D is more acidic than propanoic acid. What is P? It is alpha bromoacid. It's an alpha halogenated acid. When you substitute a halogen at the alpha position, remember that the halogen is electronegative. It attracts the electrons, the bonding electrons to itself. Correspondingly, the electrons of the CC bond are attracted in this direction, and correspondingly, the bonding electrons of OH attracted towards the back side of the molecule, so that expulsion of hydrogen as a proton is easier. And that is what it called as a minus inductive effect of the halogen. The minus inductive effect of the halogen makes the acid stronger. Halogenated aliphatic carboxylic acids are stronger than the unsubstituted acid because of the minus I effect. Chloroacetic acid is stronger than acetic acid. Bromoacetic acid is stronger than acetic acid. Alpha bromopropanoic acid is stronger than propanoic acid, and so on. So it's a very simple thing that is studied in connection with discussion of minus inductive effect of groups. The halogens are exercising the minus inductive effect by virtue of their electronegativity, and therefore this acid is stronger. It is more acidic than propanoic acid is a correct statement. P is more acidic than propanoic acid is a correct statement, and therefore there are two statements which are correct. C and D are correct statements, whereas A and B are wrong statements. The question is not at all tough. Again, dealing with the basic details, but you have to remember two reactions here. One is the Hell-Wohlhard-Zielinski reaction, alpha halogenation of aliphatic carboxylic acid, and the other is the Gabriel phthalimide synthesis, and here the phthalimide is treated with this bromo compound, and you have the bromine atom replaced by the phthalimide ion to form the substituted compound, which on hydrolysis generates the amino group. Actually, that is discussed in connection with the preparation of primary amines, pure primary amines in the context of discussion of primary amines, but the same reaction is applied here to get an amino acid in this case. Okay, so I think that is full. Thank you for listening. Okay.